This section's title indicates we're diving deep into how the scikit learns. GaussianProcessRegressor works, specifically focusing on its prediction method. I'll explain what the predict method does and how to interpret its results. The core question asks us to determine which statements are correct regarding the predict method of the GaussianProcessRegressor, GPR, a powerful tool for regression problems using Gaussian processes. I'll carefully examine each statement to identify the true ones. The predict method in GPR is what I use to get predictions from the model I've already trained. I feed it new data, and it outputs predictions, a point estimate of the likely value. This parameter controls the level of detail in the predict method output. When set to true I get not only the mean prediction but also a measure of the uncertainty associated with that prediction. By setting return _std equals true the predict method returns two things: the mean, average, prediction, and the standard deviation. The standard deviation is a crucial measure of how uncertain I am about the prediction. A large standard deviation means I have high uncertainty, while a small one implies more confidence in the prediction. It's like saying, I predict X, but I'm plus or minus Y uncertain. This statement is correct. With return _std equals true I get two arrays. One containing the predicted values, the means, and another showing the standard deviations for each prediction. This is also correct. The standard deviation directly tells me how much the actual value might deviate from the predicted value. A larger standard deviation signals greater uncertainty. This statement is incorrect, as I just explained. It is only true when return _std is false. When return _std is true, I get two arrays, not one. This statement is also false. The kernel is crucial. It defines how data points relate and directly affects the predictions and their uncertainty levels. The kernel choice fundamentally shapes the predictions. I'm focusing on the predict method of the GaussianProcessRegressor. This method gives us predictions from our trained model. It's like asking the model, what do you think the output will be for this new input? This is a crucial setting. Setting return_std to true means I'll get more than just a prediction. I'll also receive a measure of the model's confidence in that prediction. Think of it like getting a prediction along with an error bar. This statement is incorrect. When the predict method actually returns two arrays, one for the average prediction and another showing how much the prediction might vary. This is correct. I'll get two arrays back. One contains the average predictions, and the other contains the standard deviation, which measures the uncertainty of each prediction. Precisely. The standard deviation tells me how much the predictions could vary. A higher number means more uncertainty in the prediction. That's wrong. The kernel, which defines how data points relate to each other, significantly influences the model's predictions and how uncertain those predictions are. It's a critical part of the model building. This question is basically asking us to test our knowledge of the GaussianProcessRegressor predict method and how it works when we set return_std to true. I'm focusing on the predict method of the GaussianProcessRegressor. This method gives us predictions for new data points. Think of it like asking the model, what do you think the value will be here? This quiz question tests my understanding of how the predict method works, specifically when I ask for the prediction uncertainty, standard deviation. When I set return _std equals true I get two things back: the average prediction, the mean, and a measure of how uncertain that prediction is, the standard deviation. It's like getting both a best guess and a confidence level with that guess. That standard deviation I mentioned? It's a direct measure of my model's uncertainty. A bigger standard deviation means I'm less certain about the prediction. Imagine it like a wide range on a thermometer. There's more uncertainty about the temperature. This is false. The kernel is a crucial part of how the GaussianProcessRegressor works. It dictates the relationships between data points, which directly affects predictions and their uncertainty. A different kernel would lead to different predictions and confidence levels. It's like changing the ingredients of a cake. The result will be significantly different. This setting tells the predict method to include the standard deviation of its prediction with the mean prediction itself. I'm analyzing the predict method of Sklearn's GaussianProcessRegressor, a tool we use for making predictions with uncertainty estimates. This question asks you to check your understanding of how the predict method behaves in Sklearn's Gaussian process regression when you want to know the prediction uncertainty. When you set return_std equals true you get two things back: the average prediction and a measure of how uncertain that prediction is. I'll explain it. It returns the average prediction and the standard deviation in the prediction. The standard deviation tells us how spread out the possible predictions could be. A bigger standard deviation means we are less sure about the prediction. This statement is wrong. The kernel, a function describing how data points relate strongly, influences what the model predicts and how uncertain those predictions are. The kernel is like a recipe. It determines how the model creates predictions and how confident it is in those predictions. The choice of kernel heavily impacts both the prediction's average and its uncertainty. This question asks you to identify correct statements about the behavior of the GaussianProcessRegressor predict method in Sklearn, specifically when you set the return_std parameter to true. We'll examine each statement's accuracy. This tests your understanding of how Gaussian processes handle prediction uncertainty. I see this statement as incorrect. When you set return_std equals true the predict method doesn't just give you one array, it gives you two. One for the average prediction and another showing how uncertain that prediction is. This statement is correct. When I set return_std equals true the GaussianProcessRegressor gives two arrays as a result. The first shows the average prediction at each point, and the second shows the standard deviation, which represents the uncertainty of that prediction. That's how we quantify prediction uncertainty. That's right. The standard deviation is a measure of uncertainty. A higher standard deviation means the model is less confident in its prediction. It's a useful measure of how much the prediction might vary. I find this statement wrong. The kernel is super important. It shapes the model's predictions and the uncertainty associated with them. It's a fundamental component of the GaussianProcessRegressor. Changing the kernel will absolutely change the predictions and their uncertainties. I'm focusing on the GaussianProcessRegressor in Sklearn, specifically its predict method. This method gives you predictions from your trained model. This is the core question. We're checking your understanding of how the predict method works and what information it gives back. This statement is correct. When you set return_std equals true you get two things back: the average predicted value, the mean, and how spread out those predictions are likely to be, the standard deviation. Think of it like this: you're not just getting a single guess, you're getting a guess and a measure of your confidence in that guess. Absolutely. The standard deviation shows how uncertain the model is about its prediction. A higher number means a wider range of possibilities, and thus, more uncertainty. It's a fantastic way to quantify how much faith to put in your model's prediction at a given point. This is a crucial parameter in the predict method. Setting it to true tells the method to include the standard deviation in the output, alongside the mean prediction, which helps you assess the uncertainty inherent in your predictions. This refers to the predict method within the Sklearn GaussianProcessRegressor. It's the function we use to get predictions from our trained model. This question asks you to identify which statements accurately describe the output of the predict method when the return_std parameter is set to true. This means the method should return both the prediction and its uncertainty. This specifically highlights that we're looking at the behavior of the "predict" method when the optional argument "return_std" is set to "true". This setting changes the method's output, making it return both a mean prediction and a standard deviation. This refers to the machine learning model you built. It's a model that uses Gaussian process regression. Remember, this is a type of model that gives us not only the best guess but also a measure of how sure we are about that guess. When "return_std" equals true, the "predict" method returns two pieces of information: the mean prediction, which is our best guess, and the standard deviation, which is our measure of uncertainty. A small standard deviation means we're very confident, while a larger one means we're less sure. This is the data we use to train our model and make future predictions. The "predict" method takes new input data points to produce predictions for them. This statement is incorrect because, when I said "return_std" equals true, the "predict" method will actually return two arrays. One array will be for the mean prediction, and the other array will be for the standard deviation. This is correct. Setting "return_std" equals true tells the "predict" method to return both the mean prediction, the model's best guess, and the standard deviation, a measure of how uncertain the model is about that guess. This is also correct. The standard deviation quantifies the uncertainty of each prediction. A larger standard deviation indicates the model is less confident in its prediction. This statement is wrong. The kernel is what controls the behavior and assumptions of the Gaussian process regression model, so it influences both the predicted mean and the uncertainty.